Okay, now we're actually starting a new chapter called Sequence and Series. So what we're going to look at first is just some general ideas about patterns and sequences and series. Can anybody tell me, to start with, what a sequence is?
A series of numbers.
Yeah, but you've just replaced sequence with series, so I need the definition to be a bit... and actually that's not too bad, but it needs to be a little bit more than that. Anyone know what a sequence is? Yeah, that's it. I just would change the word group though.
It's a series.
And not series. Better, but not that. It's sequential is just the adjective, isn't it? A sequence is a sequential thing, you know. Right, what is it? What is it? You see, the reason I'm saying it's not group is because group could be kind of all muddled up. So we need a different word.
Collection.
Getting better. I would just say an ordered list. Now that's important though, because if I said ABC is in a group, right? Is it still true to say CBA is in the same group? Well, yeah. By calling it an ordered list, I make it clear that it's a list, and the order does matter. The first is the first, and the second is the second, and you can't just swap them. Okay. So it's an ordered list that follows a rule. So it's not just random. Yeah. I can see, Aoife, you're still thinking about 5A. Yeah. I think you should just let it go for the moment. You could work on it later then.
Because I did the 3 equations.
Oh, you got the 3 equations?
Yeah.
And do you think you could solve them?
Yeah, maybe.
Maybe. Okay, right. We'll find out tomorrow. So, okay. Now, I will practice some simple ones. I'll give you some sequences, and I want you to figure out what the rule is and tell me what's next. So, can I scroll down? Yes?
Yeah.
Right. So here's the first one. Nice and simple. I'll say 2, 4, 6, 8. What's the next one? 10. Okay. And what is the rule here?
N plus 2.
I know, just keep it simple, just in English. The rule is add 2.
Yeah.
Just add 2. You get the next one. Start at 2 and add 2. Right, here's another one, a little harder now. 1, 2, 4, 7. I think I've got that right. Yeah. I'll do one more. 11. So what's the next one here?
It's
16. But what's the rule?
adding integers.
Yeah. You're adding 1, and then each time you add 1, you add 1 more. It's kind of like this. So you start off, you add 1, and then when you add 1 again, you add 1 more. So you add 2. And then you add 2, and you add 1 more, you add 3. So it's almost like, as you were saying, the integers. It's almost like you add the next natural number. So the first natural number is 1. So you add 1. Then the next natural number is 2. You add 2. And then you add 3, then you add 4, and then finally you add 5. Okay? Right, let's make them harder now. Right, what's next? I'll do one more. Okay, what's next?
56.
Yeah. 36.
36.
What's the rule, Marwan?
The forward.
They're all squares.
Yeah.
They're all squares. Yeah, okay. Right. Next one.
What's that?
4. 2, 3, 5, 7, 11, 13, 17. What's next? What's the rule? They're prime numbers. Prime numbers. Right, I'll do 2 more. Let's start making it a little bit harder. It's pi, isn't it? 3.141592. What's next? Nice. Nice try. You had a 1 in 10 chance of seeming like a genius, but what is it? 6? Who's the genius? It is 6, yeah.
Then 5.
You have your calculator out now. Right. Last one. And if you do get this one, then you really are a genius. Okay, so.
This 5.
No, it's not actually. Right. Now you see, maybe lose track now. Hang on.
Pascal triangle.
It is not. Okay. So what's next?
Damn it.
Yeah, but you know, if you guess it right, I'm just going to ask you what's the rule, and then. So, what's next? It's not 1. Maybe it's 2. Maybe it's 3. Can you see? Can you see what the rule is? They're not random. There's actually a rule here. No.
So I'll come up.
3?
No.
9.
No, still not 9. It wasn't 9 a minute ago. It's still not 9.
7.
No. Right, you're like saying all the numbers and you're not getting it. No, not 4.
It's more than 10.
No. It's less than 10.
Between 1 and 100. But
It's less than 10.
it's less than 10, but like, it's also between 1 and 10.
But it's not a negative.
Minus 1. 2.
Yeah, 2. But why 2? Why 2? Why 2?
It's easy now. 1 plus 1 plus 1, 3.
Yeah,
3 plus 1, 4.
yeah.
Then
Yes, I go on. 4 plus 1 then, yeah? Right. Now I'll show you how to make this sequence, okay? So listen very carefully. This is it's a silly one, but it just goes to show you a sequence needs to follow a rule, but it doesn't have to be a mathematical rule. It just has to be a rule, okay? So what you do is you start off, you write down the number 1. And then you say how many numbers you have and what numbers you have. So listen carefully. I'll say, I have 1, 1. How many 1s do I have on the screen right now? 1 of them, right? So I have 1, 1. So I write down next 1, 1. Because I just said I have 1, 1. Now what do I have?
You have 3, 1.
Now what do I have?
1, 3.
I have 4 1s and 1 3. Now what do I have?
You have 1, 2, 3, 4, 5, 6,
6 1s,
and 1,
2
3,
3s, and then
1,
1 4.
Woo!
There we go. Yeah.
Nonsense.
Yeah. I think. Back it up there. Right.
Can this actually be an example?
Yeah. So the reason I did this example was when people first were studying this maybe 200 years ago. The idea was that sequences could only follow a formula, an equation. But the idea here is a sequence can follow any well-defined, clear rule. As long as each time you use the rule, you get the same answer. It's not random. You know, there's nothing random here. Once you understand the rule, you get the exact same answer as everyone else. Yeah. Actually, the last sequence I just want to do, which is kind of easier, but I think you might have seen this before. It's a famous sequence. You go 2, 3, 5, 8, and what's next? Now you should get this because you almost gave me this rule a minute ago. 13, and the next one? 21. And what's the rule here? For my buddy up here, what's the rule? No, he's going to tell me because he told me it a minute ago.
I said it.
You actually said it, yeah. Didn't he?
Okay, 1 plus 1, 2,
Yeah.
plus 3, 5.
Yeah, there you go. Okay, so you add 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8, 13, 8 plus 13, 21. This is a famous sequence. I wonder if anyone has heard of it
Yes,
before.
now you do it on your calculator when you're bored.
Yes, okay. But do you know the name of this sequence? Have you seen it before?
Yes.
Yeah, Fibonacci sequence.
Mm.
Fibonacci sequence.
That's Italian.
Huh? Fibonacci?
Is Italian?
I'm not sure because it is Italian. Fib something. Fibonacci. It's he's an Italian. He was an Italian mathematician. Huh?
I already found the general.
You're still doing 5A.
Yeah.
Okay, good job. Good job. All right. Anyways, that's just kind of a warm up on sequences. So, what we'll have a look at now. Obviously, we can't be dealing with sequences in such a manner. We need to deal with them as formulas. So, a typical way to write a formula is like this. Let me just get this plugged back in. Now, I know different countries use different terms, so you could say something like Tn equals, for example, 3 plus 4n. And Tn means the nth term. So, for example, T1 is the first term, T2, second, and T3, the third term. And you can use this formula to generate a sequence. And you start with n is 1. So if n is 1, what is the first term here? 7. If n is 2? 11. If n is 3? 15. And this is how you can generate the term. What's nice about this is you can just jump to any term. So you could jump all the way down the sequence to the 100th term, T100. And what would that be? 403. So this is what you might call a direct formula. It can directly tell you the term. You just simply say what you want, in this case like 100, and it can tell you what the 100th term is. Okay, and who uses T from their home country? T, yeah. And there's another letter that's sometimes used. S is something a bit different, which we'll do later. But A, yeah. D, okay, and then here what's quite common is to use U and V. So you could have a sequence like this, for example. UN, sequence U, is n squared. What's the first term? 1. Second term? Third term? 9, etc. Squaring all as you go. You get the idea. Okay. Now, I think that's fine. You probably have seen this before. But what you might not have seen next is what's called a recursive formula. So you want to write this example down carefully. I'll give you an example like this. I tell you the first term is, let's say, whatever it is, 2. Start at 2. Okay. Here's the formula. Tn plus 1 equals 1 plus 1 over Tn. Now this is quite different to the two examples I just did for you. Okay. I don't know if anyone has seen this before. It's called the recursive formula. What is missing from this formula? You don't have an n anymore, do you? You just have a Tn and a Tn plus 1. Now, what might be helpful is if you change this into an English sentence. What would Tn plus 1 represent in the sequence? No, T1 is the first term. T2 is the second term. What is Tn plus 1?
The next term.
Yeah, the next term after n. After n, right? So this would be, you could just, I'll just put it in quotation marks as in the next term after the nth term. Okay? And what does what does Tn represent here? The nth term. So I'll just put 1 over, I'll just write this term. In my head, I'm picturing my sequence, okay? And maybe I'm imagining I'm here at this term. And this is the nth term. Then what's this one here? This is what I'm calling the next term. So you can think about the formula like this. It's basically saying the next term is 1 plus 1 over the term that I'm at. Let's try this out. So let's say I start with 2 as my first term. What is the third term? What is the next term? Well, according to my formula, it should be 1 plus 1 over 2. Very good. Which is 1.5.
Yeah.
Yes. Yeah, okay. Now, how do I get the next term?
You do
It-
1.5.
Yeah, it'd be 1 plus 1 over 1.5 is 1.67. It would be great if you could check.
Yes.
Okay, right. Now, the next term will be 1 plus 1 over 1.67. Is that 1.75? 1.59? Well, okay. I guess I can only do 3 of them in my head. Right, 1.59. And so on and so on. Etc. No, you can't. You can't say that because you just told me 30 seconds ago what to do. You couldn't have forgotten what you just told me 30 seconds ago. I heard you say it. I'm baffled. I can't understand this. Right, let's start again. Right, I start with 2. Now, how do I get the next term?
1 plus 1 over 2.
Yeah, that's it.
Just change the 2.
So that's, what's that, 1.5. Right, how'd you get the next one? No, just bellow. How'd you get the next one?
1 plus 1 over 1.5.
Yeah, so, I didn't imagine hearing you saying this. So why are you saying you don't understand when you do understand? Yeah, you do. Okay. Right, I forgot now. What did we say the next one was? 1.67 and then 1.59. Okay. Now, of course, it'll take you some time to generate the sequence. So what I want to show you on the calculator is there's a very nice way on the calculator to do this rather quickly. So, and it works on any calculator. And I'll pick a different one as an example. So let's give you a minute to write this example down and then we'll do a different one. Sorry. Okay, did you write that down? Yeah, okay. Let me give you a different example here. I'll just write it a little bit differently. I'll say xn equals minus 5 minus 1 over xn minus 1. Now don't worry, it's not that different, okay? Imagine I'm at the nth term. What is the one before it called? N minus 1. And the one after it? N plus 1. And this is the nth, that's a th there, nth term. So, this xn and this xn minus 1. The xn minus 1 is the term before, and the xn is this term here. So once again, it's the same logic. This, does it represent the term I'm at or the next term? What do you think? No. Next term. I'm going to imagine I'm standing here at n minus 1. I'm here. if I'm at the x, okay, let me write this a little clearer a second. Right, xn plus 1. What's next? Xn plus 2. What was previous? Xn minus 1, Xn minus 2. Xn minus 2. Now, which terms are being used in my recursive formula? Xn and Xn minus 1. Now, where will I imagine I'm standing in the sequence? That I'm standing here. Okay, so I'm here, and my formula is giving me a relationship between this and this. So I'll call this here, and then I'll call this next. Now, if I go back to the formula, let's translate it into English. What is this guy representing? The next term is equal to minus 5 minus 1 over the term that I'm currently at. Okay? Now, I'm going to show you how you can use the calculator to generate the terms rather quickly. Oh, I also need to tell you where to start. So I'll tell you to start at 3. Okay, so watch carefully. What you do, and it works on any calculator, okay, any calculator, you type in the first term. So where do I start in this sequence? I'm starting at 3. Okay, so you just type in 3, you press equals, and then you press AC to clear it. Have you done that? Yeah? Now, the reason for doing that is because this key here, answer, what value is stored in answer? 3. So let's test it. It is. Okay. Now, let's think about what we need to type in here. We need to type in minus 5 minus 1 over, 3. Minus 5 minus 1 over answer. So now I get the next term, minus 16 over 3. Yeah. But now what is stored in the answer key? Minus 16 over 3. So if I recalculate this, it's like I'm typing in minus 5 minus 1 over minus 16 over 3. So simply pressing equal generates the next term. Etc. I know, man, like this is better than PS4. Like this is just... Right. Yeah. Now, watch. What term? That's the 4th term, yeah? 5th term, 6th term. Now watch carefully. 6th term, 7th term, 8th term. What's happening? It's not really changing, is it? 9th term, 10th term, 11th term, 12th term, 13th term. Well, if it does change, we can't see it anymore. Yeah. So what has this sequence done? Describe its behavior. What has it done? It's kind of reached a what we call a limit. There's a word to describe that. Does anyone know it? Converge, yeah. This is convergent to about minus 4.79. So you can say this sequence will converge. Yeah, and we don't need for today write down what the limit is. That will be another lesson. We just need to say it will converge. Okay? What's wrong, Marwan? Are you sure? I'm going to give you a sequence. I want you to generate many terms. Then I want you to tell me if you think it will converge or not converge. Okay, can I scroll down? Oh, no, you need to write it down, sorry. Yeah. When you're ready, I want you to use your calculator to tell me what is going to happen with this sequence U. Correct, it doesn't converge. What's happening each time, Rahman? It keeps increasing, doesn't it? So the first term is 1. The next term is 1.1. And then what's it like? 1.2 and so on and so on and so on. It keeps increasing, 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 increasing. So this one does not converge. Does anyone know the word that describes if it doesn't converge? The opposite here. Yeah. This sequence will diverge. Yeah? Has anybody seen this before in school, these recursive sequences, or is this a new topic?
Yeah.
It's a new-
I've heard it before.
We'll study how to find the limit in a different lesson, yeah. For today, we just need to check with the calculator if we think it converges or diverges. Okay. Obviously, convergent sequences are nicer, because you can then calculate the limit it's convergent to. Yeah?
Well, like,
Yeah. There is one more example I want you to do using the calculator. Let me give it to you. We'll call this sequence V, and I'll tell you to start at 1. And let me make sure I get this formula right. Vn plus 1 equals something interesting. No, I'll start at -1 there, that's more interesting. And Vn plus 1, I'll tell you, will equal minus Vn. Alright. Tell me what this sequence is doing. Yeah, what's happening here? You start at, it's like this, isn't it? This is periodic. It seems to be repeating. Now, technically speaking, I want you to tell me, does that make it a convergent or a divergent sequence? Divergent, okay? A sequence which is not convergent is automatically divergent. So, this is divergent. Okay? Is okay? Yeah. Now, as Kay-Hong and others were saying, for this lesson, I don't need you to calculate the limit, the convergent limit. That would be in a separate lesson. I just want you, I think it comes up in question 5, I just want you to look at the sequence later in the worksheet and just, in your judgment, does it converge or diverge? There actually is a way to test for certain if it converges or diverges. Because there's some situations where the sequence, it looks like it converges, but it doesn't. It actually diverges. And there's maybe some situation where the sequence might look like it diverges, but in the end it converges. Okay, we're just making an estimate for today. Let me tell you which ones to try now. So homework then will be 1 ABC, 2 ABC, 3 ABC, 4. Hold on. A, B, F, G, and 5. Yeah, the same. 5 is just 4. 5 and 4 go together. In number 4, I ask you to generate 6 terms of the sequence. And then in number 5, I ask you to use your judgment to decide if the sequences you got were convergent or divergent. Yeah. Just do those 5. That'd be good. Yes. Light. What? Turn it off.
What's the follow?
What?
No, not really.
No,
Like,
don't.
it's getting loose.
Don't worry. Don't worry. Yeah, don't.
I'm just saying, like, for safety, in case.
Ah, yeah.
Because nobody touched it.
Because like last class.
Is it moving or is it stationary?
No, nobody touched it for
Yeah.
it to get to this position, which means it can continue falling.
Possibly, but it looks stationary to me.
Yeah, it looks.
Yeah.
Yeah.
Look, I'm willing to take this risk. I think right now it would probably only land maybe near you, but not on you. Would you say?
But I care about Abdul.
No, I think he's all right. You're not directly under it, are you? You're all right. Yeah.
Because it's because of the class reps, like I care.
Yeah. Thank you, Mr. Safety Monitor,
Yeah, you're welcome.
for pointing that out. I'll have the construction team work on it immediately.
Thank you. Thank you.
Right, do you have those written down, those ones? Yeah.